Assalamualaikum and good day. So today my partner and I will present about chemical hazardous waste. So my name is Nurul Najah binti Juso and my partner is Nur Hanim Akila. So I will start the presentation. So introduction for hazardous waste is defined as the waste that poses substantial or potential threat to public health or the environment. This waste can be generated from industrial activity, medical processes, agricultural operation, and even household product. Hazardous waste is characterized by its operation that make it dangerous or potentially harmful. So these properties include toxicity, reactivity, ignitability, and corrosivity. So type of chemical treatment methods divide by SIG, which is neutralization, oxidation, reduction, precipitation, hydrolysis, and dechlorination. So let's start with the neutralization. Neutralization is a process where the pH of hazardous waste is adjusted by reacting an acid with a base or vice versa. This method is vital because it reduces the corrosive nature of the waste, making it safer to handle, transport, and dispose of. By converting hazardous, acidic, or basic substance into neutral compound, we can significantly lower their potential harm. During the neutralization process, an acid reacts with a base to form salt and water. For example, when hydrochloric acid reacts with sodium hydroxide, the product are sodium chloride and water. The reaction not only neutralizes the hazardous neutral of acid and base, but also produce harmless byproduct. Here you can see the chemical equation for this reaction in the slide. Neutralization has several practical applications across various industries. For instance, acidic wastewater from industrial processes can be treated with sodium hydroxide to neutralize its pH, making it safer for discharge into water body. Conversely, basic bases as that form certain manufacturing processes can be neutralized using hydrochloric acid. By adjusting pH level before and after treatment, we ensure the waste is safer for disposal and less harmful to the environment. Next, let's discuss oxidation. So, oxidation involves adding an oxidizing agent to hazardous waste to convert toxic substance into less harmful or more easily removable form. So, this method is particularly effective for treating organic contaminants such as phenol and hydrocarbon and certain inorganic substances including some metal. So, this goal is transform this harmful compound into less toxic or more stable form. In the oxidation process, a substance reacts with the oxidizing agent, resulting in a less harmful product. So, for example, phenolic waste can be treated with the hydrogen peroxide, converting it into less toxic compound like benzoquinone and water. So, the chemical reaction can be represented as in the slide. So this process effective reduce the toxicity of the waste, making it safer for further treatment or disposal. Oxidation is widely used in various applications. One of common example is the treatment of phenolic waste with hydrogen peroxide. So another important application is oxidation of chromium 3 to chromium 4. Why chromium 4 is toxic, and converting its more manageable form can aid and its removal or further treatment. Reduction is another crucial chemical treatment method. It involves adding reducing agent to hazardous waste to convert toxic substance into less harmful or more manageable form. So this method is particularly useful for treating heavy metals such as chromium and mercury and certain organic compounds. Reduction can effectively lower the toxicity and mobility of hazardous waste, facilitating safer disposal. In the reduction process, a substance reacts with a reducing agent, resulting in less harmful product. For example, hexavalent chromium can be reduced to trivalent chromium using sodium bisulfite. The chemical reaction is as follows in the slide. The reaction significantly reduced the toxicity of chromium and making it safer for disposal. Reduction has several practical applications. For example, reducing hexavalent chromium to trivalent chromium using sodium bisulfite is a common practice in industrial wastewater treatment. Another is the reduction of nitrobenzene to aniline using iron powder. So these processes help in reducing the toxicity and mobility of hazardous waste, making it safer for handling and disposal.
I will be discussing a critical method in the chemical treatment of hazardous waste, known as precipitation. This method is highly effective in treating wastewater containing hazardous metals, commonly found in industries such as mining and metal plating. What is chemical precipitation? Chemical precipitation is a process that causes the loss of soluble or insoluble forms of substances from a solution. By adding a specific reagent, we can convert dissolved contaminants into solid particles, which can then be easily removed from the water. Precipitation is often utilized in conjunction with additional treatment options to enhance its effectiveness. For instance, it can be combined with filtration, sedimentation, or flotation processes to ensure thorough removal of contaminants. This method is particularly efficient in handling wastewater containing hazardous metals. These metals often originate from sectors like mining, where large quantities of metal-laden water need to be treated, or from metal plating and finishing industries, which produce wastewater rich in toxic metals. Lime or calcium hydroxide is the most commonly used reagents in the precipitation process. When added to wastewater, lime reacts with dissolved metals to form insoluble metal hydroxides. These hydroxides then precipitate out of the solution, forming solid particles that can be removed through sedimentation or filtration. This method is especially helpful for changing dangerous heavy metals into a less mobile, insoluble state before being disposed of in a landfill. For example, consider the precipitation of cadmium as its hydroxides by the use of sodium hydroxide. The reaction can be represented as follows. In this reaction, cadmium ions in the wastewater react with hydroxide ions provided by sodium hydroxide, forming cadmium hydroxide, which is insoluble and can be precipitated out of the solution. Precipitation of cadmium hydroxide. For example, cadmium ions in solutions are precipitated as cadmium hydroxides by the addition of sodium hydroxide. Here's a detailed explanation. Cadmium ions are dissolved in an aqueous solution, making them highly mobile and potentially harmful if released into the environment. When sodium hydroxide is added to the solution, it dissociates into sodium ions and hydroxide ions. The hydroxide ions react with the cadmium ions to form cadmium hydroxides, which is insoluble in water. The reaction produces a solid precipitate that can be separated from the liquid phase. The solid cadmium hydroxide precipitate can be removed from the solution through filtration, sedimentation, or centrifugation. Advantages of precipitation. Reduction of mobility. By converting soluble heavy metals into insoluble forms, their mobility is greatly reduced, minimizing the risk of contamination to soil and groundwater. The next one is of disposal. The insoluble precipitates can be safely disposed of in landfills as they are less likely to reach into the environment compared to their soluble counterparts. Last but not least, cost-effective. Precipitation is a relatively simple and cost-effective method for treating heavy metals containing waste streams. The next one are hydrolysis. Hydrolysis is another important chemical treatment method for hazardous waste. It involves the reaction of water with a substance leading to its decomposition and the formation of new products. This process can be used to detoxify and break down hazardous chemicals into less harmful or more manageable forms. Hydrolysis reactions involve the breaking of chemical bonds in the presence of water. The general reaction can be represented as AB react with H2O, produce AH and BOH, where AB is the hazardous compounds and AH and BOH are the hydrolysis products. Often, hydrolysis reactions require a catalyst, which can be an acid, base, or an enzyme to proceed at a significant rate. Types of hydrolysis. There are three main types of hydrolysis, each with its unique applications and mechanisms. First, acid hydrolysis. Acid hydrolysis involves the use of acidic conditions to break down complex molecules. It is often used to degrade esters, amide, and other organic compounds. For example, in the presence of strong acids like hydrochloric acids, ester can be hydrolyzed into their corresponding alcohols and carboxylic acids. The next one are base hydrolysis. Base hydrolysis, also known as saponification, utilize basic conditions to hydrolyze esters and amides, converting them into alcohols and salts of carboxylic acids. A common example is the hydrolysis of fats, which are esters in the presence of a strong base like sodium hydroxide, resulting in glycerol and soap. The last one is enzymatic hydrolysis, that employs specific enzymes to catalyze the hydrolysis of complex molecules. This method is more selective and operates under milder conditions compared to the acid or base hydrolysis. Enzymatic hydrolysis is often used in the biodegradation of organic pollutants, where enzymes break down large molecules into smaller, more manageable forms. Next, I will talk about advantages of hydrolysis. The first one, detoxification. Hydrolysis can convert highly toxic substances into less toxic or non-toxic compounds, making the waste safer to handle and dispose of. The next one are versatility. This method can be applied to a wide range of hazardous substances, including organic and inorganic compounds. The last one are environmentally friendly. Hydrolysis typically uses water and mud conditions, making it an environmentally benign process compared to some other chemical treatments. Chemical treatment of hazardous waste also includes dechlorination or dehalogenation. Chemical dechlorination is a chemical process that removes chlorine from a substance, rendering the original chemical less toxic. This process uses glycols, alcohols, and water as their primary reagents. The two most common versions of chemical dechlorination are glycolate dehalogenation and base catalyst decomposition. The first one are glycolate dehalogenation. The alkali metal hydroxide portion of the reagent reacts with chlorine in the contaminant and forms a non-toxic salts. It consists of 5 steps: prepare, react, separate, wash, and dewater. During preparation step, the contaminated waste or soil is excavated, whereafter it is mixed with the reagent in a large heated container reactor. The next one are base catalyst decomposition. This process involves combining contaminated soil with sodium bicarbonate. The chlorinated chemicals are subsequently removed from the soil by evaporating this combination while it is heated in a reactor. After that, the condensed pollutants are heated in a reactor and reacts with the variety of chemicals including sodium hydroxide to dechlorinate them. Applications of dechlorination or dehalogenation in hazardous waste treatment. It can be used in PCBs or dioxins. Dechlorination is widely used to treat waste containing polychlorinated biphenyls, PCB, and dioxins, both of which are highly toxic and persistent in the environment. The next one are chlorinated solvents. It used for degrading chlorinated solvents such as TCE, trichloroethylene, and PCE, tetrachloroethylene, which are common contaminants in groundwater. The last one, it can be used in pesticides, which is effective in breaking down chlorinated pesticides like DDT, making the residues safer for disposal. There are several advantages to using dechlorination as a method for treating hazardous waste. Dechlorination can treat contaminated material on site, reducing the need for transportation and the associated risks. Next, the use of an enclosed vessel at marked temperature and pressure results in no air emissions or water discharge, making the process environmentally friendly. The second one is produce of gas are collected and recovered for treatment, ensuring that no harmful gases are released into the environment. Apart from that, cost recovery. Some costs can be recovered by recycling reagents used in the process, making it a cost-effective solution. However, there are also some disadvantages and considerations to keep in mind. There is an absence of information regarding the toxicity of certain compounds used in the process, specifically polyethylene glycol (PEG) and dimethyl sulfoxide (DMSO). This uncertainty necessitates careful handling and further research to ensure safety. In conclusion, chemical treatment of hazardous waste encompasses several methods including neutralization, oxidation, reduction, precipitation, hydrolysis, and dechlorination. These processes effectively reduce the toxicity, reactivity, and mobility of hazardous substances, making waste management safer and more environmentally friendly. By transforming hazardous materials into less harmful forms, this chemical treatment plays a crucial role in protecting human health and the environment from the adverse effects of hazardous waste. That's all from me. Thank you.